Japan has taken a groundbreaking step by creating the world's first robot with living human skin, shocking people all over the world. This $10 billion innovation blurs the line between humans and machines, combining advanced robotics with organic material. In this video, we will also explore advanced humanoid robots and other impressive innovations from Japan. At the University of Tokyo, under the leadership of Professor Shoji Takuchi, researchers have embarked on an innovative project to create robots that feature living human skin. The goal of this research is to make robots more human-like in appearance and functionality by covering them with real skin cells. Unlike traditional artificial materials used for robots, living skin offers a more realistic texture and response, bridging the gap between humans and robots. This skin is grown using cultured human cells that are layered over the robot's body. The living skin can heal itself and even grow in response to environmental conditions, which adds to its potential for long-term applications. While this research is still in its early stages, it represents a leap forward in biohybrid technologies, as robots could one day be indistinguishable from humans in their appearance. Erica, launched in 2015, was hailed as the most beautiful and intelligent android at the time. While several female-like robots have since made headlines, Erica remains one of the most realistic and visually harmonious. Developed in Japan, Erica focuses on mastering social interaction rather than dangerous or military functions. Her creators aim to make her a research platform for advancing human-to-robot interaction, particularly in emotional and social contexts. Recently, the team has been teaching Erica how and when to laugh during conversations, emphasizing the importance of humor in human interaction. This challenge requires Erica to not only recognize laughter, but also determine the appropriate kind of response. Understanding human laughter involves complex emotional cues, timing, and context, which the researchers are working to integrate into Erica's AI. Erica's ability to engage with humor will further enhance her communication skills, helping her navigate more natural conversations with humans. Unlike robots designed for physical tasks or security purposes, Erica's focus is on advancing empathy and social intelligence, aligning with her role as a conversational android. Japanese scientists, led by Professor Hiroshi Ishiguro of Osaka University, have developed a robotic duplicate of Japan's Minister for Digital Technology, Taro. This initiative is part of a research and development project designed to explore the potential of conducting social events remotely using robotic avatars. The 175 centimeters tall robot, which has 52 movable parts across its face, arms, and waist, closely mirrors Kono in appearance and movements. Although the robot is yet to be fully tested, it will eventually participate in trials to interact with people and deliver speeches, with researchers aiming to determine if people perceive the robotic duplicate in the same way as the actual minister. This project allows the minister to control his avatar remotely, enabling him to engage in public events without needing to be physically present. The broader goal of this research is to investigate public attitudes toward robotic clones and assess whether these avatars could eventually replace humans in various roles. Shiorin is a humanoid robot developed by the Japanese company Species, designed with a highly realistic aesthetic, including detailed facial features, lifelike skin, and natural body proportions. This robot is powered by advanced artificial intelligence, allowing it to engage in dynamic conversations with users. It can understand and respond to questions, maintain dialogue, and express a range of emotions. Equipped with servo motors, Shiorin can perform various movements, such as hand gestures, head turns, and facial expressions, enhancing its ability to interact in a lifelike manner. Shiorin also features sophisticated speech recognition and voice synthesis technology, enabling it to comprehend and respond to voice commands accurately. This combination of AI and motorized articulation makes its interactions fluid and human-like. Its ability to display different emotions through subtle facial expressions adds to its appeal, especially in customer service, education, and social settings where natural communication is essential. The University of Tokyo has made waves in robotics research by demonstrating a humanoid robot named Musashi that can drive a car. This achievement represents a significant leap in humanoid robotics, focusing on practical, real-world applications. Musashi is designed to operate vehicles in a way that mimics human behavior closely, with sensors and AI that allow it to understand its environment and make real-time decisions. The robot can manipulate the steering wheel, use pedals, and respond to traffic signals, showcasing its ability to navigate a car through complex driving scenarios. What sets Musashi apart from autonomous vehicle technologies is its humanoid design, allowing it to operate traditional vehicles that do not need to be specially adapted for robot use. This has immense potential in industries like transportation and logistics, where human-like robots could supplement or replace human drivers in areas experiencing labor shortages. The project also offers valuable insights into how robots can interact with environments specifically designed for humans, such as the interior of a car. Orex Rentec, a Japanese tech rental agency, has launched a robot rental service called RoboRen, which features the android Mirai Madoka. This robot, capable of functioning as a multilingual secretary fluent in English, Chinese, and Japanese, is designed to assist in professional environments. Although Mirai resembles robots developed by Toshiba, it remains unclear if Toshiba co-developed it with Alab, or if Alab designed it based on Toshiba's specifications. Currently on display at Orex Rentec's Tokyo Robot Lab showroom, access to view Mirai is restricted, as the space is primarily for potential renters. Mirai stands out with its elegant design, capable of sophisticated facial expressions, including moving its eyes and lips, making it a valuable addition to the growing field of service robots. Nadine is a humanoid social robot modeled on Professor Nadia Magnanat Thalmann. The robot has a strong human likeness, with natural-looking skin, hair, and realistic hands. Nadine is socially intelligent, returning greetings, making eye contact, and remembering all conversations. It can answer questions autonomously in several languages and simulate emotions through gestures and facial expressions, depending on the interaction content. Nadine can recognize people it has previously seen and engage in flowing conversations. It has a personality that changes based on what is said to it. Nadine features 27 degrees of freedom for facial expressions and upper body movements. It remembers facts and events related to individuals it has encountered before. Nadine can assist people with special needs by reading stories, showing images, arranging Zoom or Skype sessions, sending emails, and communicating with family members. West Japan Railways has developed a groundbreaking humanoid robot for railway maintenance, addressing labor shortages and ensuring safer work practices. This giant robot is operated via virtual reality, allowing human workers to control its movements from a safe distance. One of the robot's primary functions is to handle heavy machinery, such as installing or removing electrical lines and performing repairs at significant heights. Equipped with hydraulic arms that mimic human motions, the robot offers precision while lifting and moving large, heavy equipment. Its humanoid form allows it to operate in environments designed for human workers, eliminating the need for extensive modifications to existing infrastructure. This robot is specifically designed to work in hazardous environments where human safety is a concern, such as near high-voltage power lines or unstable railway structures. The implementation of this robot could mark a major shift in infrastructure maintenance, not only in Japan but globally, as industries seek more efficient ways to address labor shortages and increase safety in high-risk jobs. Thanks for watching, and make sure to hit the like button, subscribe, and put notifications on to stay updated on everything related to AI and robotics.